All right, in this video we're going to talk about what an empirical formula is, and then I'm going to show you how to calculate the empirical formula of a substance. So this is, you probably know this is sugar, and this is what is known as its molecular formula. We've already talked about this, but it tells you the number of atoms present in a molecule or in 1 mole of the substance. What the empirical formula is, and the empirical formula is the lowest denominator of the things in the compound. So if you look at this, we can divide this whole thing by 6, right? We can divide by 6 and end up with this, CH2O. CH2O is the empirical formula of C6H12O6. Now, I could ask this question to see if you understand empirical formula. Could you tell me another substance that would have the same empirical formula? Well, there's many of them, right? Just multiply this by, say, 2, and you would end up with C2H4O2. This is acetone. Or you could multiply by 4 and end up with C4H8O4. And go on and on and on. There's infinite numbers of compounds that would have the empirical formula CH2O. Well, you might ask, well, why is it even important then to have this if so many compounds have it in common? Well, let's take a look at why it is important. Earlier, when we knew the formula of a compound, so remember, I think we did this one, CaCO3, we were able to work from the formula to get the molar mass. But in chemistry, often what happens is you'll do a reaction, something will happen, and you'll be left with a new product. And you might not know what the product is. So the empirical formula is a way to go from knowing some things about the molar mass of the product, working backwards, and figuring out what it is. It's being a sleuth, being a detective, and it's the fun part of chemistry. So let's say, for example, that we do a reaction and we make a product, and that the only thing we know about this substance is that... So here's one way that this works for chemists. So, alright, so let's take a look here at how this would work for a chemist. So I have a ring stand, and in the ring stand I'm going to put a crucible, and inside the crucible I'm going to put some nickel. It's a metal, not a nickel the money, but nickel the metal. And then we'll have our Bunsen burner flame underneath here. Okay, and we're going to heat that nickel. Now we know some things about the nickel. We know the mass of the nickel. The mass of the nickel before we start heating it is 0.2636 grams. Now, as we heat it, it begins to react with the oxygen in the air, and when we're done, the mass of the nickel plus the oxygen is 0.3354 grams. So we have a substance in here in our crucible that is now nickel and oxygen, and we need to figure out what the formula is. So to figure out the formula, we first can find the empirical formula. So to do that, we're going to need to know how much nickel and how much oxygen are present. Well, in our compound, we know that there is, in our compound, we know that there is 0.2636 grams of nickel. And the amount of oxygen can be found by subtracting from this number the amount of nickel. Why does this have more mass? Well, because of the oxygen. So the amount of oxygen is the difference between these two numbers. When you subtract, you get, for a mass of oxygen, you get a number of 0.26 of 0.0718 grams of oxygen. And now what we're going to do with that is we're going to figure out the number of moles of each of these. Now remember, we cannot compare grams of atoms to each other. Right? The bowling ball and ping pong balls example, 10 grams of ping pong balls is not the same number as 10 grams of bowling ball because they have different masses. So we should convert to moles. So to convert this to moles, we're going to use our conversion factor of the molar mass. So for the nickel, the molar mass is 58.69 grams of nickel and 1 mole. And for oxygen, 1 mole is 16 grams of oxygen. We do both of these calculations and we get this number, 0.00449 moles. Now, what does that tell us? Well, what it tells us is the ratio of nickel to oxygen in the compound. And if you're good at math, you'll see that it's a 1-to-1 ratio. And if you're not great, and you can't, not if you're not great, if your math is not able to show you this, all you have to do is pick one of the numbers and divide both of the numbers by that number. So since they're the same number, if I divide both of these by 0.00449, I get the number 1. And that will be, in the empirical formula, that will be the ratio of nickel to oxygen. So the empirical formula is NiO. Now, we don't know the molecular formula. That's the next step. But that would be how you would calculate the empirical formula of a compound.